Hello and welcome to the next session of Introduction to Autonomous Systems. In the last segment, if you recall, we had introduced the idea of a knowledge based agent, and we had also looked at, from a very broad perspective, the format of this knowledge base, in which we said that there are sentences based on a typical representational language. In the same context, we talked about the syntax of that language as well as the semantic of that language, which essentially was an act of ascertaining the truth or falsity of a statement, whereas syntax would be ensuring that it was a properly formed sentence. Now, one of the most appropriate manner in which we look at these sentences are in the context of logic, particularly because there is a requirement of testing the truth or the falsity of a statement, which falls squarely in the domain of logic. So, let us begin this session with a small exposure to the concept of logic. If we go back and look at the standard context of logic, we find that a sentence can either be true or false in each possible word, and there are no intermediates, which means either it is true or it is false. In this regard, we also need to differentiate between model, which is a precise description, and possible words which are potentially real words in which the agent might or might not be. So, we now need to understand this differentiation, that when we say a model, it is a description of a possible scenario, while the agent is going to operate in a real world scenario, which may or may not be same as the model that have been created. Then we say that if a sentence alpha is true in some model M, we say that M satisfies alpha. What we are trying to say is that in some context a statement would be true, and it will be true only in that context. Let us now bring in the idea of a logical reasoning, which, if you recall from our last session, is an important element of arriving at an inference or a conclusion or leading to a decision and an action. In fact, reasoning is an essential attribute of intelligence, as all of us know, because we keep doing this all the time. Either consciously or subconsciously, we reason out a particular action or a decision based on which an action is taken. So, we need to set up a mechanism to reason out the sentences in a logical manner. So, this is where the logic enters into the working of a knowledge based agent, where the knowledge base is nothing but a large collection of sentences which are syntactically and semantically appropriately connected to the concept of logic. So, in this context, we need to connect sentences in a way that later ones follow logically from the preceding ones. So, inference process is essentially an idea of logical deduction, that we take a sentence or a group of sentences and based on that we come up with a sentence which essentially is a conclusion or a result of the earlier sentences. In the context of logical reasoning, this whole process of arriving at a sentence which is a conclusion from given sentences, we typically call entailment process, and it is mathematically represented as alpha with a symbol which contains a vertical bar and equal sign. Let us call it, for the brevity case, alpha entails beta, where alpha and beta are two sentences. What we are saying is that beta follows from alpha. In other words, if we were to kind of use a lay person's interpretation, we would say that if alpha is true, then beta is true, and similar kind of interpretations now could be made from a different perspective as well. Now, let us make it a little bit more mathematically rigorous, this whole process of logical reasoning and entailment. So, in a formal way we say that alpha entails beta, which means beta follows from alpha if and only if, which means it is a very strict condition, necessary as well as sufficient, if in every model in which alpha is true, beta is also true and can be mathematically expressed as follows: alpha entails beta if and only if alpha as expressed in model A belongs to models which are appropriate for the same models for beta as well, and M or capital M here we call it a collection of models. If you remember from the previous session, we had given an example of an algebraic context in which we had said that x plus y equal to 4 is a statement, and this is true in all the models where values of x and y are such that their sum always turns out to be 4. So, this is what we mean by collection of models. We should also need to note here that this representation is unidirectional in the sense that assertion of alpha is stronger than that of beta. Let me give you an example here, that if I put x equal to 0 as a premise, then it will always imply that x multiplied by y equal to 0 regardless of the value of y, but the reverse is not true, because if we say that x into y equal to 0, either x could be 0 or y could be 0 or both could be 0. Any one of those possibilities exists. So, it does not clearly imply x equal to 0. This is what we mean by saying that this representation of entailment is unidirectional. Let us now move over to the next idea of logic, that is entailment and its impact on inference. Entailment is an important action that helps us to come to logical conclusions, or commonly what we are going to call inferences, which means a kind of a conclusion. In this regard, we can think of knowledge base as a single sentence that asserts all other sentences, which means if our knowledge base contains information which is true in whichever context that knowledge base is going to be used, then all the sentences which are going to be following the property of entailment, they are all going to be true statements. And that brings us to an important requirement with regard to the knowledge base, that we have to ensure that the statements which are in the knowledge base have been verified to be either true or false in a given context, and all possible models that represent that worldly situation. In fact, we can also say it in another way by saying that knowledge base is going to be false in any model that contradicts what the agent knows. Therefore, we see that inference requires that all possible models are checked for their truth or falsehood before a conclusion can be arrived at. We see, so, and you realize that this is going to be a challenging task, because first of all you have to ensure that you have taken into account all possible models that are applicable for that particular real world scenario. And then we have to set up a procedure which will verify whether that particular statement or the knowledge base is true in that a particular model or is false, and then complete this whole process for all the models. In fact, people have compared this somewhat with like searching for a needle in a haystack. The analogy says that the needle is the inference or the conclusion, while the knowledge base is the haystack. And as your knowledge base grows, you can see that this haystack will become larger and larger, and you still have only a single inference to find. In fact, the only thing which we know at this stage is that the needle, so called needle, or the logical conclusion or the inference is contained in the knowledge base, but still we need to go through all the models before arriving at it, which means you still have to find it. The fact that it is contained in the knowledge base is only the beginning of the problem. The real solution would be when we are able to arrive at the right logical conclusion for a given model. Let us consider an example to understand what we are talking about. For example, if we consider a knowledge base that asserts that there is no object in the room in every model. Suppose that is the knowledge base which is asserting that there is no object in the room in every model. Then a conclusion alpha 1 that there is no object is true, which means we say that knowledge base entails the conclusion alpha 1. This is how we talk about inference using entailment process in the context of knowledge based agents. On the other hand, if knowledge base asserts that there is no object in the room in every model, then a conclusion alpha 2 that there is an object is false, which means we now say that knowledge base does not entail alpha 2, and this is symbolically represented by a slash on the equality sign to indicate that this relation is not an entailment, which means alpha 2 does not logically follow from the knowledge base KB. This now can be stated as follows. The whole process of inference. We say that enumerate all possible models to check that alpha is true in all models in which knowledge base is true, or in a more compact notation which we commonly employ when we are talking about entailment or an inference process, that knowledge base in model M belongs to the inference in the same set of models. So, which means that this connection exists. Let us now take this a little further by looking at entailment inference connection. If we were to use the haystack analogy, entailment is similar to saying that there is a needle in it. That is what entailment says, that if I have an entailment, it indicates that there is a needle or there is a conclusion which is there in this whole knowledge base, while the inference is the actual process of finding it. And that is why you will realize that both of these are connected and equally important, because it is necessary first to establish whether the conclusion that you are interested in drawing is part of the knowledge base or not, and then you must have a way of arriving at that particular inference by actually searching for it through the various statements which are part of your knowledge base. Now, this can be formally differentiated through the following statement. So, let us call that process of finding an inference as an algorithm. Let us say an algorithm which is going through the knowledge base, doing the entailment process and ultimately finding that particular conclusion. So, we say that algorithm I derives alpha from KB. Indirectly what it means is that a particular algorithm is capable of extracting that particular inference from the knowledge base, or is capable of, using the analogy, finding that needle corresponding to alpha in the haystack corresponding to knowledge base beta, and symbolically it is expressed as KB in the ith algorithm connected to alpha. So, basically it is now an alpha KB connection through the algorithm. So, now this you need to understand. This is not same as entailment. Entailment just says that in the knowledge base, all the models that you have collected, it is possible to find a conclusion alpha within the same model set. Now, we are going to the next step and saying that there is an algorithm alpha which can find this alpha from the knowledge base, and that is an important point, because this is where we will have to now look at the possibility of creating an algorithm I which can derive alpha from the knowledge base. In fact, there is another aspect that we need to be aware of, that an inference algorithm, which means now we are talking about what should be the property of such an algorithm. The property of such an algorithm should be that it derives only the entailed sentences, and as a consequence is sound or truth preserving, which is a highly desirable property, which means I cannot have a knowledge base which arrives at kind of a wrong conclusion or a conclusion which is patently false. Many times as human beings we end up doing this, that our reasoning process or the algorithm, if it is not sound, we may end up with drawing a conclusion that may not be applicable. I will give you an example. Suppose let us say that I am standing at a place and I see all around darkness, when very dark during daytime, not much daylight. Now, it is possible that from my knowledge base I may falsely conclude that what I see on the horizon are all clouds, and that it is going to rain in a while. Whereas it is quite possible that those may be just a haze, a fog, a smoke, and there may not be any rain. So, my conclusion that it is going to rain is not correct, because I have not used perhaps a sound algorithm which preserves the truth. In fact, the converse is very risky. An unsound algorithm, as I was just explaining, could make things up in a way and in a way discover non-existent needles, which means the conclusions that do not exist, you may arrive at those conclusions, which means you could make things up if you do not preserve the truth. Sometimes we imagine things, and based on that we come up with a conclusion which is not correct in a given context or the models that are applicable for the particular problem. And it is found that the model checking procedure, wherever it is applicable, is a sound process of arriving at an inference, which means this is the only way in which you will ensure that you do not discover non-existent needles and you essentially arrive at the right conclusion for the given problem. To give you an example, if I have the statement x plus y equal to 4, now I must come up with all possible combinations of x and y, what I would call the models, which will either prove that relation or disprove that relation before saying that a particular combination is true or false. Unless I have checked for that model or that particular combination, suppose I have checked only for x equal to 3 and y equal to 1, and somebody gives me x equal to 5 and y equal to minus 1, which I have not checked, I may label it as false, whereas actually it is true. So, you realize the issues and pitfalls if you do not use a sound procedure where you actually check all the models, and that brings us to this important element of this whole inference process called the completeness of the algorithm. So, not only the algorithm needs to be sound, which means it will preserve the truth, it should not draw wrong conclusions, but it should also be complete, which means it has to check every model, and there is also an implied effect that the process can derive any sentence that is entailed, which means it should not miss any. And you will find that these are going to be essential attributes of any algorithm which would claim to arrive at the inferences which are logically correct. Now, how does one ensure this completeness? Of course, in the real world, we know that the knowledge base for a given problem has a finite size, and hence it is intuitive to realize that if an inference is possible, model checking process can arrive at it, which means we are indirectly saying that if there is a conclusion, then it can be drawn. Of course, there are many knowledge bases that have infinite consequences, and that is why I brought this problem of x plus y equal to 4. Now, actually you will realize that there are countably infinite combinations of x and y which will either satisfy this relation or not satisfy this relation, and then you will find that establishing the completeness will become a big issue. Of course, by and large it has been found that there are some procedures which are considered to be complete for logic that are able to handle many types of knowledge bases. Of course, some type of knowledge bases it may still have an issue, but by and large there are procedures that are able to handle many types of knowledge bases. And this brings us to the following conclusion. So, we say that if knowledge base is true in the real world, then any sentence derived from it through a sound inference procedure is also true in the real world. So, soundness is important. Completeness, to the extent possible, we should be in a position to ensure, and with these two attributes in place, you should be able to generate a sound inference which is true in the real world. So, now I just want to show this whole process of inference in the form of a graph. So, let us say that we have a representation, we have a word. So, we are sentences through semantics which establishes the truth or falsity of a statement. We assert the aspects of the real world. These sentences will again entail other sentences which verify the truth or falsity of aspect of the real world. So, we say that all the aspects of the real world logically follow from the aspects of the real world from the other sentences. So, this is essentially your whole entailment process. So, we are saying that if the knowledge base is true in the real world, then the inference that you have drawn from that knowledge base is also true in the real world if you have used a sound process. It is to be noted that sentences are physical configurations of the agent, while reasoning is a process that constructs new configurations from the old ones. We will clarify these points in subsequent interpretations and examples. So, but to conclude this segment, we say that logical reasoning to arrive at a conclusion involves verifying the truth or falsehood of the knowledge base. The above process makes use of concept of entailment in order to come up with a sound and complete algorithm for arriving at a conclusion. So, with that we come to the end of this session, and we will continue this particular thread further in our subsequent sessions. So, bye for now and see you in the next session.